Hey there YouTube, Super Brain AK here. And as you can see, we got the giant buck converter all set up on the bench. Made some 10 gauge power wires, bridged the terminals with copper buffs. But, so in the mailbag video I just showed you a quick overview, but I guess I'll get into depth and test it in this video. I did make a slight error in saying that the wire gauge was the same as the coil on the boost converters. But grabbing my grandfather's scales, I can see that these wires are about 1.15, whereas these or 1.48. Oop, 1.42. So a little bit bigger. And of course it's twice the height. So let's look at what chips it has on board. Bring you around, grab my flashlight, which I put right here. And we can see it's got the input terminals here. This is input positive, input negative. And you can see it's got some reverse polarity protection diodes there. Well, Mosfets actually. That resistor in the back there is onto the gate, which goes onto the diode. So when this is positive, the gate gets pulled low with that diode. But if this is positive, then the diode blocks it, pulling the gate high, turning it on, turning the buck converter on. Oh, and this is a 40 volt input, 50 amp output buck converter. So it can actually only go to 32 volts on the output. But we'll take a look at the data sheet real quick. And over on my tablet, and see 2.8 milliohms, 132 amps. Big long part number for that. So if we can follow the positive in, goes along some 63 volt 470 microfarad capacitors. Goes into the Mosfets underneath the heatsink, their surface mount. Nice big fan. Goes into the gigantic coil. You can see there that it goes out, and then there's other diodes, or I mean Mosfets, from the ground to here, so it's synchronous onto some more 63 volt 470 microfarad capacitors, or no, 50 volt capacitors, sorry. And that trace, this is a positive, goes under the board up to here, and there's the giant current shunt. If you can see that, the LCB-050A, and there we go. Oh yeah, 050B, which is plus or minus 50 amp, 40 millivolts per amp, bidirectional. Not sure why they used a bidirectional here. There's the data or usage of it, but it's a Hall effect current sensor. 100 microohm conductor. So how this works is, well, it's synchronous buck converter, all the Mosfets are there. Positive current shunt, which is awesome. So the negatives are the same. You don't have to worry about floating voltages. So the positive comes in around, tapping off of this last capacitor. You can see these two wires there going off to here. One's going to this buck converter, one's going to this inductor, and another 63 volt 330 microfarad capacitor. And then this is a voltage sensing tap. This is a, let's see if you can read it, XL7050A. 7005A, 150 kilohertz, 0.4 amp output, 80 volt buck converter. So that is powering the fans, which gets turned on and off. There's a voltage divider which comes back from the fan, which turns this on and off, and then there's this trace here which comes back to the microcontroller. And here there's another XL7000 series 7015 there, which is 0.8 amps, same 80 volts. So that is supplying the voltage, probably 12 volts, for various things, maybe the Mosfet driver and whatnot. And then that goes, so that's its inductor there, goes to a tank capacitor, 16 volt, 220 microfarad, through another inductor, and to this linear regulator with some bulk capacitance there. Sorry for shaking. And then this is another tiny little buck converter. Don't have the data sheet of that, but you can see the numbers there. It's just a linear regulator. Probably this one's 3.3. That might be something else. Maybe this is 5 volts. This is 3.3. Yeah, power wires come off. And you see it's got a screen. It's just an LCD inverted screen. On the back, we've got a STM32. And then over here, we've got a big diode, which comes from ground to the output side of the, the input side of the inductor. So it can use the diode if the Mosfets for some reason don't turn on. There's also a thermistor under the foam there. You can see it snaking off under that cap, the trace, going right back to the microcontroller. And these traces actually going back to here, which bunch of lines come down over to here, which is TC594C, which, whoops, sorry for hitting you, TL594 PWM control circuit. And yeah, so that outputs to this other chip, IR210, which is 2104, which is a half bridge driver. So that's how it works. Uses a half bridge driver to turn on and off the Mosfets. So I better get this thing powered on and running. But let me show you the circuit. I've got my 12 volt power supplies in series. I've got a video on those, how to do those properly. That comes in through this, so this is the input, which goes here, and then the output goes through this one, which I have a separate power supply, because on this side I can't turn it on and off because it's just a giant resistor. So here are my calculations. I don't know if you guys remember when I was testing this power supply with a bunch of current. or this coil with a bunch of current. I had some of this nichrome wire on these two heat sinks, just clipped on, and it was using 6 of these little tabs on the same nichrome wire that I stole from a glass cooktop. So yeah, that's about 0.1 ohms per tab, and so that was using 6 tabs, and it was a couple in parallel. I don't know if it was 2 or 3. You'll have to see the video, but it's 0.1 ohms per tab, so it was 0.6 ohms of each one of those strands in that video. Anyway, these I calculated to be 0.2. I needed 0.24 ohms, 12 volts, 50 amps, 0.24 ohms. So I wanted to do 6 of them at 1.44 ohms each. So I needed them to be 14 tabs long. They're going to pass 8 amps each. So, and then I built it, put them in parallel. Got 2.23 ohms passing 10 amps through it. So it's 0.223 ohms. So I have a 0.223 ohm, heck of a lot of current load bank, and I've got my big server fans there with my PWM controller. So without further ado, we'll get on with the video. So, input, output, hopefully you can see these right. Go ahead and get things turned on here. Sorry for the noise. These are server power supplies. Powering up. Come on. I was putting it in wrong, I think. Yep. Okay. Input, output. Power supply's on, see what happens. Alright, we're 22 amps already. So that guy, it's full voltage. Oops. Move these fans on. So, as you can see, I can turn on and off backlight with the bottom button. Change the displays. There's voltage, there's current. And you can see input power, output power. Now, this is only 12 gauge, so I'm going to lose a bit of voltage on here. So this is 10 gauge. So 12 gauge can't really handle 50 amps, but it's silicone wire, so it's fine. So we got 5 volts, 22 amps. I'm using the constant current feature right now. There you go, 5 volts. 21.3. Oh, fan just kicked on. Because at 40 degrees Celsius. I think it kicks on at 40 and completely disables everything at 65. So I'll keep the voltage and the current on here just to show the losses. So, bring the current up all the way. Bring these fans up. Bring down a little bit. Get the current all the way. Well, it's 35. 326 watts in, 293 watts out. An advantage, there's kind of cool in my room right now. Alright, 40 amps out, 415 watts in, 376 watts out. 25 amps. 527 watts in, 480 watts out. Not entirely lossless. There we go, 50 amps. 12 volts. Perfect. It's probably going to kick out on over temperature. 652 in, 596 out. Does it go higher than 50 amps? I wonder. Nope. Kicked into overcurrent. So we'll let it cool down. Once it hits 40, it'll kick back in. There it goes. 87. 50. 51.6 is all it'll do. Unless it's going to voltage mode? No, I don't think so. Oh, it'll go 50 more. Nope, too hot. I wonder what it'll jump to. I don't know why this is reading very weird voltages when there's no voltage on the input. It's very weird about these guys. This is an isolated supply. Alright. 55 amps almost. 785 watts in, 723 watts out. My wires are getting pretty warm. Plenty of heat coming from these. So what current can it sustain? I think it can sustain 40 amps. So it kicks on at 30. Go to 45 amps. And keep an eye on the temperature. 55C, getting up there. I'm going to turn it down a little more because it's going pretty quick. Wonder how my server power supplies are doing. Yeah, they're a little warm. 495 watts in, 452 watts out. Now, of course, it's probably going to be a little bit different because the voltage on here is higher. It's like 44 amps is about as much as we can do sustained. So, 450 watts. Not bad. Yeah, 45. Yeah, it's probably going to hit 64. C. Alright. Yeah, this heatsink probably needs better thermal connection. So maybe 45 amps. Down to 25. And shut it down. Well, that is a successful test. I didn't blow it up. So, I will thank you guys for watching. And let me know what you want me to blow up. with this thing. So now I have 32 volts at 50 amps. So, I will see you guys in the next video. Thanks for watching.